Question 2. The line L is shown in the diagram. It has equation x plus 2y plus 8 equals 0 and cuts the x-axis at A. The line K has equation y equals negative 1 over 2 times x plus 6 and is not shown on the diagram. Copy or trace the diagram into your writing booklet. Part A. Find the coordinates of A. The first step is to copy the diagram as instructed in the question into your writing booklet. So here it is. Draw the x and y axes at right angles to each other, of course, using a ruler. And here is line L, cutting the x-axis at point A. So A represents the x-intercept of line L. And we're asked for the coordinates of point A. Now, since A is the x-intercept, that means the y-coordinate of point A is 0. So to find the x-coordinate of point A, we let y equals 0 and then substitute 0 for y into the equation here and then solve for x. So x plus 2 times 0 plus 8 equals 0. Now 2 times 0 is 0. So we're left with x plus 8 equals 0, which gives us a solution x equals negative 8. Therefore, the coordinates of A are negative 8, 0. Part B. Explain why K is parallel to L. Since the equation of line K is in gradient intercept form, that is in the form y equals mx plus c, in this case y equals negative 1 over 2 or negative half times x plus 6, we can read the gradient directly from the equation. And the gradient of line K is the coefficient of x, which is negative 1 over 2. So the gradient of K is negative 1 over 2. Now to find the gradient of line L, we need to rearrange its equation, which is currently in general form, and we need to express it in gradient intercept form, in the form y equals mx plus c. So firstly, making 2y the subject, we can move the x and the 8 over to the right hand side, and we get 2y is equal to negative x minus 8. Then dividing all terms by 2 to make y the subject, we get y is equal to negative 1 over 2 times x minus 4. Hence the gradient of line L is the coefficient of x, which is negative 1 over 2. So the gradient of line K is equal to the gradient of line L, which equals negative 1 over 2. Therefore K is parallel to L. Part C. Draw the graph of K on your diagram, indicating where it cuts the axes. Given that the equation of line K is y equals negative half times x plus 6, which is in gradient intercept form, we can read the y-intercept directly from the equation, and the y-intercept is 6. So that's where the line crosses the y-axis. Now to find the x-intercept, we let y equals 0 in the original equation and then solve for x, because the y-coordinate of the x-intercept is 0. So we have this equation. 0 is equal to negative half times x plus 6. Rearranging the equation to isolate half x, we get half x is equal to 6, which means x is equal to 12. So the x-intercept of line K is 12. Sketching the line on the diagram, we get this line here. Y-intercept of 6 here, and x-intercept of 12 here. Notice also that line K is parallel to line L. Part D. Shade the region x plus 2y plus 8 less than or equal to 0 on your diagram. The region we are going to shade is either going to be on or above line L or on or below line L. And the way we can check is if we test a particular point, let's say the origin 0, 0, and checking to see that it's in the region x plus 2y plus 8 less than or equal to 0. So substituting x equals 0 and y equals 0 into the left-hand side of the inequality, we have left-hand side is equal to 0 plus 2 times 0 plus 8, which equals 8. Now 8 is not less than or equal to 0. Hence the origin 0, 0 does not lie in the region. Therefore the region to be shaded is on or below line L, and it's shown on the diagram here. Part E. Write down a pair of inequalities which define the region between K and L. From Part D, we can deduce that the region above line L is given by x plus 2y plus 8 greater than 0. Note the use of the greater than symbol, not the greater than or equals to symbol. The word between in the question implies that the region does not include line L itself, nor does it include line K either. Now the region below line K is given by the inequality y less than negative half x plus 6. Therefore, the region between K and L is given by the intersection of the inequalities x plus 2y plus 8 greater than 0 and y less than negative half x plus 6. Part F. Show that P 8, 2 lies on K. We want to show that the equation y equals negative half times x plus 6 is true, given that x equals 8 and y equals 2. Now from the right hand side, substituting x equals 8, we get negative half times 8 plus 6, which equals 2, and y equals 2. So right hand side is equal to left hand side, therefore 8, 2 lies on line K. Part G. Find the perpendicular distance from P to L. The perpendicular distance, or the shortest distance from a point with coordinates u, v to a line with equation in general form ax plus by plus c equals 0 is given by the formula distance d is equal to the absolute value of au plus bv plus c over the square root of a squared plus b squared. Now recall the equation of line L is x plus 2y plus 8 equals 0, and point P has coordinates 8, 2. So in this case, A is equal to 1, B is equal to 2, C is equal to 8, U is equal to 8, and V is equal to 2. So distance D is equal to the absolute value of 1 times 8 plus 2 times 2 plus 8 over the square root of 1 squared plus 2 squared. And evaluating this expression, we get 20 over the square root of 5, since what's inside the absolute values is positive anyway. And if we rationalise the denominator, we get 4 root 5 units. Part H. Q 4, negative 6 lies on L. Show that Q is the point on L which is closest to P. If interval QP is perpendicular to line L, then Q is the point on L that is closest to P. Now from part B, the gradient of line L is negative 1 over 2. Now the gradient of QP can be found using the 2-point gradient formula, that is y2 minus y1 in brackets divided by x2 minus x1 in brackets. So that's change in y divided by change in x, or rise divided by run. And then substituting the correct coordinates for y2, y1, x2 and x1, we get 2 minus negative 6 in brackets divided by 8 minus 4 in brackets, which equals 8 divided by 4, which equals 2. Now gradient QP times gradient L is equal to 2 times negative 1 over 2, which equals negative 1. So if two lines or intervals are perpendicular to one another, the product of the gradients will equal negative 1, which is the case here. Hence, QP is perpendicular to line L, therefore Q is the point on L closest to P.